Hi friends, very good morning. Welcome to our class. Welcome to Anu Academy. Okay, let us start today's class. We will start today's class. I think yesterday we have started engineering mechanics. In engineering mechanics, in our yesterday's class, we came to know about the classification of engineering mechanics, and we came to know about the basic terms like rigid body, mass, force. Okay, in connection to that, our previous class, we will continue today's class. Okay, in today's class we will we will discuss uh, regarding the force. Okay, today's class we will discuss the topic regarding the force. Okay, so the topic in which we are going to discuss today is about the principle of transmissibility of a force. Okay, the principle the principle of transmissibility of a force. Okay, so yesterday we learned what is a force, what are the units of a force. Now we will see how what is the principle of transmissibility is teaching us regarding this force. Okay, right. Now here just we will see some definition. The principle of transmissibility of a force states that the external effect of a force on a rigid body is the same for all points of application along its line of action. That is, it is independent of the point of application. Okay, now we will take few diagrams here. With the help of these diagrams, we will learn the concept of the principle of this transmissibility of a force. Okay, so first here we will take one bar, right? This is one bar. Okay, so this is lying here, this bar is lying. Okay, now the motion of the block will be the same within, it is pushed at A. Okay, it is pushed at A, and it is pulled at B. Okay, so here the principle of transmissibility of a force is saying that the motion of the block will be same whether it is pushed at A or pulled at B. Okay, so here like that we have to learn this principle of transmissibility, right? So we can consider this as P. Okay, right. Next we will take some system of two bars. Okay, so like that here I will draw, this is one bar. Okay, it is fixed, this bar is fixed. Okay, and it is, we are taking one more bar. Okay, this is also fixed, right? And this is hinged here at point, let this is C, D and E. Okay, so here the system of two bars hinged together at D is not inherently rigid. It is the hinged supports of C and E that restrict relative movements of the bars. Okay, so in this case, therefore, since we do not have a single rigid body, the external reactions and the internal effects will be different if P is applied first at A. Okay, if P is applied first at A and then at B. Okay, then at B. So in this diagram, what we are learning from this principle of transmissibility is that the external reactions and the internal effects will be different if P is applied first at A and then at B. Okay, like that we have to understand the principle of transmissibility. Next one more diagram we'll take here. Here, instead of this fixed point E, if we replace this E with a roller, okay, if we replace this E with a roller, how the principle of transmissibility of a force is teaching us, we will see. Okay, so let us take the diagram here. Same diagram we will draw. Okay, so if you are getting a question regarding this principle of transmissibility, you can explain with this diagram. Okay, this is the roller, right? So same diagram we can draw here. Showing the connectivity of these two bars, how we are giving the connection to this roller, right? It is again hinged, points are same, C, E, and this is D. Okay, now we will see here how the things are changing, because previous diagram the 2 points C and E are fixed now, but here the E is replaced here with this roller, right? So however, if the hinge support at E is replaced by roller support and another bar CE, okay, another bar CE, so we can show here the connectivity. It is showing like a truss shape. Okay, it is showing like a truss shape, right, like this. Okay, so this is the roller as we have discussed. We shall have a seeing this diagram, we shall have a triangular truss equivalent to a single rigid body. Okay, seeing this diagram we can show that we are having a triangular truss equivalent to a single rigid body. Here the difference here it is the external reactions will be same whether P is applied at A or B. Okay, if P is applied, if this is P is applied at A or P is applied at B. Okay, so here we can see the external reactions will be the same whether P is applied at A or P is applied at B, although the internal effects will differ since P applied at A tends to bend bar CD. Okay, so once P is applied at A, it tends to bend the bar C and D. So C and D, so it tends to bend, and P is acting at B tends to bend the bar D and E. Okay, it tends to, so once P is applied at A, what is happening? C and D starts bending, and once P is applied at B, what is happening here? D and E starts bending. Okay, so with these three diagrams we can understand the principle of transmissibility of a force. Okay, so with this, if we give a name, this is A and this is B and this is C. Here the conclusion of this principle of transmissibility of a force, we can say that principle of transmissibility is valid for A and for C, but it is not valid for B. Okay, so here we can write principle of transmissibility, principle of transmissibility, okay, is valid, we can write is valid for A and C, but not for B. Okay, Okay friends, so if you are getting a question regarding the principle of transmissibility of a force, with the help of these three diagrams you can explain the transmissibility of a force. Okay, so that's all for today's class. Think all of you understood today's class. If you are having any doubts regarding this class, okay, you can put your doubts in the comments box. I will give a reply. So please subscribe our channel. Please like, share, and please discuss with your friends regarding our channel, the class work going on in our channel. Thank you very much. Thank you for watching.